For centuries, we've stared at the night sky wondering if another world, one truly like ours, exists somewhere out there. We found hints, spectral data, chemical traces, anomalies that suggest something familiar, something almost terrestrial. But now, for the first time in history, we have an image. NASA's James Webb Space Telescope has captured something unprecedented, the first real image of an exoplanet that may be more like Earth than anything we've seen before. This is not just another rocky body orbiting a distant star. It's a world with signs that hint at life, an atmosphere full of carbon compounds and possibly even a vast ocean hidden beneath its clouds. Elon Musk himself has called this discovery one of the greatest moments in space exploration. Could this be the moment we finally confirm that we are not alone? The James Webb Space Telescope has delivered something that changes everything we thought we knew about habitable world. And the more scientists analyze this data, the more questions arise. Is this planet really capable of supporting life? Could its conditions resemble those of ancient Earth? And most importantly, what else is waiting to be discovered? Let's dive into the details of this groundbreaking revelation. 120 light-years away, orbiting a cool red dwarf star in the Leo constellation, astronomers have been studying an exoplanet called K2-18b. This planet is nothing like those in our solar system. It's about 8.6 times the mass of Earth, far too massive to be a terrestrial world like ours, yet too small to be a gas giant like Neptune. For years, it has been a mystery. Was it just another inhospitable ball of gas, or could it be something more? NASA's Hubble Space Telescope first hinted that K2-18b might have a thick atmosphere filled with water vapor. This led to even bigger questions. Could this planet have an ocean beneath its atmosphere? Could it be a Hycean world, a type of planet with a hydrogen-rich sky and a vast liquid ocean beneath it? With Webb's superior instruments, scientists finally got their answer. The data confirmed the presence of carbon-bearing compounds, specifically methane and carbon dioxide. This alone was groundbreaking because it suggested an environment where complex chemistry, the kind needed for life, could be taking place. Even more intriguing, scientists found a lack of ammonia, a possible indicator that a vast water ocean may exist beneath the planet's thick atmosphere. This was the first real evidence that K2-18b might be more than just another exoplanet. It could be a place where life as we know it could actually exist. But then came something even more shocking. As scientists continued analyzing the data, they came across something that defied expectations. Buried in the atmospheric readings was a potential sign of dimethyl sulfide (DMS), a molecule that, on Earth, is only produced by biological life. Here on our planet, DMS is mostly released by marine phytoplankton, microscopic organisms that live in our oceans. If this molecule is truly present in K2-18b's atmosphere, it would mark the first time in history that a chemical exclusively associated with life has been found beyond Earth. But before we jump to conclusions, there's a catch. The detection of DMS isn't yet confirmed. The signal is faint, and scientists need more time and further observations to verify if it's really there or if it's just an anomaly. Still, the possibility alone is enough to shake the scientific world. If confirmed, it could mean that K2-18b isn't just habitable, it could already be inhabited. This discovery has sent shockwaves through the astronomy community. If K2-18b can support life, then how many other Hycean worlds are out there? Could the universe be teeming with life beneath thick hydrogen atmospheres and hidden oceans? And if life can thrive in such extreme conditions, what does that mean for the search for intelligent civilizations? But K2-18b isn't the only place where Webb has detected astonishing findings. As scientists process the data from K2-18b, the James Webb Telescope was busy making another incredible discovery, one that has completely reshaped our understanding of how the universe formed. Webb detected complex organic molecules in a galaxy that existed when the universe was only 10% of its current age. This means that large carbon-based molecules, essential building blocks of life, existed just 1.5 billion years after the Big Bang. Before this discovery, scientists believed that such complex molecules would take much longer to form. What this means is astonishing. It suggests that the early universe was much more chemically rich than we ever thought possible. If organic molecules were forming so quickly after the Big Bang, could life have emerged far earlier than we assumed? Could intelligent civilizations have existed long before Earth was even formed? And if life had a head start in the universe, where are they now? This discovery doesn't just challenge our understanding of the past. It forces us to rethink everything about how life could have spread across the cosmos. The James Webb Space Telescope has done something extraordinary. Not only has it provided the first ever direct evidence of carbon-rich atmospheres on a potentially habitable world, but it has also revealed that complex organic chemistry existed in the early universe, far earlier than expected. These discoveries are just the beginning. Webb is only getting started, and its upcoming observations could change everything. Scientists plan to use the telescope's mid-infrared spectrograph to take even deeper scans of K2-18b's atmosphere. If they confirm the presence of DMS or other biosignatures, we may be looking at the first direct evidence of extraterrestrial life. Meanwhile, astronomers are already planning to use Webb's advanced instruments to scan more Hycean worlds, planets that could hold vast oceans hidden beneath thick atmospheres. And beyond that, there are plans to aim the telescope even further back in time to detect the earliest galaxies ever formed. If Webb has already pushed back the record for detecting complex molecules by 1 billion years, what else could it reveal? Could it find the missing pieces of the origin of life itself? What if, instead of being alone in the universe, we are just one small part of something far bigger than we ever imagined? The era of guessing is over. The era of seeing the truth with our own eyes has begun. As astronomers analyzed the data coming from the James Webb Space Telescope, they realized something remarkable. Light from K2-18b's atmosphere carried more than just chemical signatures. It held a timeline, a record of what this planet has been through over millions of years. The light that Webb captured from this distant world had traveled 120 years through space before reaching us. This means that every molecule, every spectral fingerprint detected, is a snapshot of the past. If life does exist on K2-18b, what we're seeing now may no longer be accurate. Civilization could have risen and fallen in the time it took for this light to reach Earth. The planet's atmosphere could have changed. The ocean that we believe may exist could already be gone.